All right, so what I'm going to do today is go ahead and finish the rest of section 8.4 today. Just focus on just 8.4 and finish that today. All right, so far we did talk about the Cartesian coordinate system and also equations of vertical and horizontal lines. And then we talked about equations of lines and slope. Slope-intercept form, that's y equal mx plus b. And we talked about how to find the x and the y-intercept linear equations, and also how to sketch the graphs for each of the following, for each equation. Then I talked about how to determine the slope of a line through two given points. That's going to be m is equal to y2 minus y1 divided by x2 minus x1. And we did an example of that, and this is where I left off. I did parts A and B. I just need to go and finish that with parts C and D. And this dealt with writing the equation of a line determined by the given pairs of points in slope-intercept form, or in the form x equals A or y equal B. So in this case, part C was this. We had 0, negative 1/4, and 1/4, 0. And here I want to find the slope of that line going through those 2 points. So in this case, I can label this as x1, y1, and the other point x2, y2. And then we find the slope of that line first, using m is equal to y2 minus y1, all divided by x2 minus x1. And in this case here, y2 minus y1 will be 0 minus a negative 1/4. Divided by x2 minus x1, 1/4 minus 0. Then if I do 0 minus a negative 1/4, that's 1/4, because that's like 0 plus 1/4. The denominator 1/4 minus 0 is 1/4. 1/4 divided by 1/4 is how much? 1. That's just 1/4 divided by itself. Okay. So that's the slope. Now we need to write the equation using the y equal mx plus b. Now, I do have a slope of 1, which I found that out to be, and I'm going to use either one of these 2 points. Preferably, I'll use a second order pair. I'm doing that because I don't want to deal with those zeros, those negative signs. And then I substitute the x, which is 1/4, and the y, which is 0, and the m, which is 1 in this point. Slope-intercept form. So y in this case is 0, equals to m, that's going to be 1, times x, which is 1/4, and then plus b. One times a fourth will be 1/4. So this will be 0 is equal to 1/4 plus b. Then if I subtract 1/4 on both sides, get b by itself, that means b will have to be negative 1/4. Well, maybe I should have used that first order pair, because this will be like 1 times 0. Then I have a negative 1/4 on the other side. That would tell me what b is. Okay. So using y is equal to mx plus b, the equation there will be y is equal to m, which is 1, plus b, which is negative 1/4. And if I write this as 1 times x, that's x, plus or negative would be like minus 1/4. And that would be the equation of the line passing through those 2 points. Okay. Questions on part C? Okay, now part D, same thing. This time we got 0, -2, and -1, -2. -2 and -1, -2. And here I want to write the equation of that line through those 2 points. Okay. So I'm still going to be using m is equal to y2 minus y1 all divided by x2 minus x1. y1, and then this is x2, y2. In this case here, y2 minus y1, that's going to be -2 minus -2. Divided by x2 minus x1, -1 minus 0. All right, so what's -2 minus a -2? 0. And -1 minus 0 is 1, and 0 divided by -1, 0. So the slope of that line through those 2 points is 0. Now, of course, we can use the y for nx plus b. And I'm using the slope of 0. And I'll go ahead and use 0, -2. So here, y is -2 in this case, so that'd be -2 is equal to the slope, which is 0 times x, which is 0 plus b. But that's going to be easy. 0 times 0 is 0 plus the b is. So your b or your y-intercept is -2. So we just substitute the slope of 0 and the y-intercept of -2. So this will be y is equal to 0 times x plus -2. This will be 0, so you're going to be left with -2. So the equation y is equal to -2 is the equation of the line passing through those 2 points. All right, any questions about that example number 5? All right. Now let's look at this one. This is part A, B, C, and D. Here we're going to write the equation of each line, and you are given the points, and this time you are given the slope. Okay, so we don't necessarily need to use that slope formula, m is equal to y2 minus y1 divided by x2 minus x1 to find its slope. The slope is already given. So all you have to do there is just use the slope and either the first or the second ordered pair to come up with your equation. Part A, you got 2, 4, and 0, 3. And in this case, your slope is 1/2. So here the slope is 1/2, and you got the ordered pairs 2, 4, and 0, 3. All right, so now let's simplify that. Now you can use either the first order pair or the second order pair along with the slope of 1/2. I'll use that second order pair 0, 3. And that's y is equal to mx plus b. And here the y is the second number in that ordered pair. That'd be 3. That's equal to m, which is your slope, 1/2, times x, which is the first number in that ordered pair. That's 0 plus b. 1/2 of 0 is 0, so this will be 3 is equal to 0 plus b. And if I add 0 and b together, I will get b. So that means b is equal to 3. That's going to be your y-intercept. And then to write the equation, we know it's got to have an x and a y in it. So it'll be y is equal to, the slope is 1/2, so it'll be 1/2 x plus the y-intercept of 3. So y equals 1/2 x plus 3 is the equation of the line. Those 2 points and with that given slope. Okay. Questions on part A? Part B is this, the square root of 2 and 4 and 5, 4. And in this case here, your slope is 0. The slope is 0. Okay. So we know we got to use the slope of 0. And I can use either one of these 2 points. Let's use the 5 and the 4, the 5, 4, that ordered pair. I mean, you could use that first order pair of the square root of 2, 4, but let's just use the 5 and the 4 since it doesn't have radicals in it. So again, we use y equals mx plus b. So this time, this is x and that's y. So y is 4 equals your slope, that's 0, times x, which is 5, and b is what we're trying to find, so that'd be plus b. And you'll see that 0 times 5 is 0, so that'd be 4 is equal to 0 plus b, and b will have to be equal to 4. So using only the slope and the y-intercept, that'd be y is equal to, well, my slope is 0, so this would be 0x plus b, which is 4. 0 times x, that's 0, so that means I'm going to end up with y equal 4. And pretty much by looking at this, these 2 ordered pairs, you see that your y coordinates are the same. So that tells me that the slope would be equal to 0. And y equals 4 will have to be the equation of the line through those 2 points. All right, any questions about part B? Okay, part C. Here we got A comma A and F comma F where the slope is 1. Okay. Well, we're told what the slope is. The slope there is 1. So we know we're going to use that slope of 1. And I can use either one of these two ordered pairs. I'll use the first one, A comma A, in the slope-intercept form, y equal mx plus b. So here this is x and this y. So here y will be A, equaling to m, that's the slope of 1, times x, which is also A, plus b. Now 1 times A will be A, so I have A is equal to A plus b. Now in this case here, we need to solve for b. Here we're adding A, so that means I need to type A on both sides. So b will be equal to, and in this case, A minus A is 0. So your y-intercept will be 0. And in this case here, using that y equal mx plus b, we just substitute only the slope and the y-intercept in slope-intercept form. So y is equal to 1 times x plus b, which is 0. And 1 times x would just be x. So the equation of that line would be y equals x. Okay. Now, part D looks like this. Here we got the square root of 3 and 8. And the other ordered pair is the square root of 3, negative 8. Now, in this case, you are told that the slope is undefined. So here we have an undefined slope. And if I have an undefined slope, who can tell me what type of line would this be? Anyone? It's got to be a vertical line, okay? Because if the slope is undefined, that means that the line is going to be vertical. And in a vertical line, the equation x equals to a is the equation of that line. But here, if you look at your ordered pairs, what's the same, your x or your y coordinate? The x's, they're all the same. So that means, in this case, the equation x is equal to square root of 3. That would be the equation of that line going through these 2 points. And of course, that slope is undefined. Okay. Any questions on part D? So with the undefined slope, pretty much you have to look at your x coordinates here, and that will tell you what the equation of the line is. X is equal to whatever your x coordinate is, because the undefined slope has a vertical line. All right, so let me go back to this. And then we're gonna talk about systems of linear equations. Systems of linear equations. So here, the mathematical descriptions of many problems involve more than one equation, each having more than one unknown, usually an x and a y. To solve such problems, we find a common solution to the equations, if it exists. Okay. And systems of equations is usually two or more equations with two or more unknowns. For this, we'll just focus on just two equations and two unknowns, and we're going to find what those unknowns are. And there are three strategies of solving a system of equations. One would be the intersection method, or graphing the two linear equations on a coordinate plane, and that point of intersection would be the solution set for that system of equations. Okay. Another strategy would be what they call the substitution method, and then the other would be the elimination method. So here we're going to pretty much focus on those three in this section. Okay. Now, I'll tell you that graphing two linear equations and finding the solution may be a little bit challenging, because you have to find out precisely where those two lines intersect. The substitution and elimination method uses algebra, because you can pretty much solve those system of equations in two variables and come up with your solution. All right, so on the next page, you can see here that when we solve a system of two linear equations, we may have three possibilities. One of them could be one solution where, in this case, the two lines intersect at a point. Or the two lines are parallel, meaning that there's no solution. If it intersects at a point, there is one solution. If it's parallel, that means they're not going to cross each other at a point. So that means that the system will have no solution. Now, you may have infinitely many solutions, as indicated here. One lies on top of the other. That means you're going to have the same line. Okay, so that means that there will be infinitely many solutions for something like this. So those are your three possibilities here. Okay. All right, let's start with this one. Start solving two linear equations using the intersection or the graphing method. Okay, so the first thing you do there is graph the two lines on the coordinate plane, y equal ax plus b and y equals cx plus d. And then you're going to locate the point, and they use u and v, the point of intersection of those two lines. That will tell you the solution. Okay. Now, usually the graphing method is commonly learned by students because it builds on their graphing techniques, and they can, in quote, see the solution to the system, which is the intersection of the two lines. So like in this example here, let's say I want to find the solution to the system of linear equations y equal 5x plus 2 and y equal negative 3x plus 10. So in this case, I got y equal 5x plus 2. And I'm going to say y equal negative 3x plus 10. Now, here. So here we're gonna graph those on the coordinate plane. All right, so let's start with the y equal 5x plus 2. And in this case here, I'm going to use some points, 5 points on the coordinate plane. I'm going to pick values of x like 0, let's say 1, and I'll say -1. And then just substitute into that equation. So for x is 0, 5 times 0 is 0, plus 2 will be 2. And then for x is 1, 5 times 1 will be 5, 5 plus 2 will be 7. And then for x is -1, 5 times a -1 will be -5, -5 plus 2 would be -3. So these are just a few ordered pairs for the graph of y equal 5x plus 2. All right, so let's plot those. Stay at 0, but go up 2, to the right 1 and up 7. And then for -1, -3 will be to the left 1 and down 3. So those 3 points should form a straight line. Okay. All right, so there we go. So that's the graphical line y equal 5x plus 2. All right, so for the other equation, y equal -3x plus 10. Okay, I'm gonna let x be 0, so this will be -3 times 0, which is 0 plus 10, which will be 10. I'm gonna try 1. -3 times 1 will be -3 plus 10 will be 7. And then finally, let's see. I'll try 2, since it's already negative. -3 times 2 is -6 plus 10 will be. So those are the ordered pairs for y equal -3x plus 10. So in this case here, 0, 10, we stay at 0, but go up 3, 6, 9, 10. That's way up here. 1, 7 to the right 1 and up 7. And then 2, 4 will be to the right 2 and up 4. If I draw the graph of the line, so that's the graph of the line, y equal -3x plus 10. And that other graph is y is equal to 5x plus 2. So pretty much you can see where this graph is intersecting. And that's at this point right here. And the ordered pair for that point of intersection of those two lines is going to be, in this case, 1, 7. Okay. So in this case here, the 0.17 represents the solution for this system of equations, y equal 5x plus 2 and y equal -3x plus 10. All right. All right, any questions on this example? Will this work in all cases? I can tell you right now, the answer there will be no. Because of the fact that you have to kind of, in this case, I free-handedly drew my X and Y axes and free-handedly drew the line. So you're probably not going to see, and even if you were to do it precisely, I mean, you're not going to be able to come up with the exact ordered pair that would satisfy that solution, okay? Because you might have something that might be in the form of a fraction for your solution for that system of equations. Okay. So the next method, well, the next two methods are going to be where you use algebraic methods. One of them is substitution, and the other one will be elimination. We'll first look at the substitution method. All right, in the substitution method, pretty much you're going to substitute an X or a Y from one equation into another equation so that you will have a system, you'll just have an equation in one variable, and then you'll be able to solve for that variable, and then use back substitution to solve for the other variable. Okay, so what I have up here is a procedure for solving a system of equations here. One, you may have to solve one of the equations for one of the variables. And my suggestion would probably to be get the variable that has a coefficient of 1, either for X or for Y by itself. That means you may have to move terms over to the opposite side. Okay. So once you solve for X or solve for Y, you'll use the substitution approach by substituting that expression for the same variable in the other equation. And then number 3 is to solve the resulting equation, and then substitute the result back into step 1 to find the other variable. This is where you do the back substitution. And then check your solutions if required, and then finally, you'll write the solution for that. And it will be in the form of an ordered pair. And that ordered pair would be the one that satisfies that system of equations. So let's look at a couple of examples that I have up here. Using the substitution method. All right, and we'll start with part A, which is 2x minus y is equal to 1, and 3x plus 4y is equal to 29. Okay. So this is what we have here. All right, and like I mentioned before, it would be best to deal with the equation that has the coefficient of 1 either in front of the X or in front of the Y. I'm going to work with this one first because the Y has the understood coefficient of 1. So I'll go ahead and get Y by itself. So I need to move the 2x over to where that 1 is by subtracting 2x on both sides. So that means I'm having negative y is equal to, and I'll put the negative 2x in front. So I have negative y is equal to negative 2x plus 1. But I still need to get y by itself. Here I got that negative in front of that y. So to get rid of that, I'll do this, divide each and every term in that equation by negative 1. So that means I'll have positive y When I divide each and every term by -1, it's going to change the sign to the opposite. So -2x divided by -1, that's positive 2x, plus 1 divided by -1 will be -1. So here I got y equal 2x minus 1. So this equation will be solved for y. Now this is where substitution comes in. Since y is equal to 2x minus 1, let's take that 2x minus 1 and substitute it for y in the other equation. That way I will have an equation in a single variable. So I'm going to take this 2x minus y equal 2x minus 1. Well, 2x minus 1 will be substituted for this y in the other equation. So here's what I'm going to have. Bring down the 3x plus 4 times y is going to be equal to 2x minus 1. And that's equal to 29. So now I have an equation in a single variable. Now I can simplify this. Bring down the 3x and then use the distributed property. 4 times 2x would be plus 8x. And then 4 times the minus 1 would be minus 4. That's equal to 29. Okay. Now let's combine some like terms here. What's 3x and 8x? 11x. So I got 11x minus 4 is equal to 29. What do I need to do to get 11x by itself? Add 4 to both sides. So 11x is equal to 33. And then divide both sides by 11. I know what x is. X is equal to 3. Now I need to find out what y is. Well, I have y equal to 2x minus 1. So let's use that and do the back substitution. We're going to substitute the x here in y equal 2x minus 1 with 3. So this is going to be y is equal to 2 times x is 3 minus 1. Times 3 will be 6, and 6 minus 1 is 5. I have x and I have y, so when we write our solution, it's always going to be an ordered pair where x goes first, y goes second. Because the ordered pairs are always going to be x comma y. So the ordered pair 3, 5 is the solution to that system of linear equations. Okay. Questions on part A? Okay. And that should read part B, not number 42. But this is part B. So we got 3x minus 2y is equal to 11. And the other equation is x plus 5y equals 15. And here I want to solve this system of equations. Which equation would be easy to work with to get the variable by itself, the first or the second? It'll be the second, because notice that the x has an understood coefficient of 1. So here I need to get x by itself. What would I need to do here to get x by itself? Yeah, subtract the 5y. So this will just be x is equal to, I can write this as 15 minus 5y. Now, these are unlike terms, so we can't combine those. Keep that in mind. So just be x equals 15 minus 5y. So here's where the substitution comes in. Since x is equal to 15 minus 5y, I'll take that 15 minus 5y, substitute it for x in that first equation. So I substituted for x in the first equation. So here's what I'm going to have. 3 times, and here x will be 15 minus 5y in the parentheses, minus 2y is equal to 11. And then we just simplify by using the distributive property. 3 times 15, that's 45, minus 3 times 5y, that's 15y, minus 2y is equal to 11. All right, next, what's negative 15y minus 2y? What was that? Negative 17, so I got 45 minus 17y equals 11. Now I need to get negative minus 17y by itself. So what do I need to do here? Subtract 45. So here you'll have negative 17y equals 11 minus 45 is how much? Negative 34. So negative 17y is equal to negative 34. Divide both sides by negative 17. You'll get y is equal to how much? 2. All right, since y is equal to 2, I need to find out what x is. Well, I've already got x by itself. That means that x minus 15, x equal 15 minus 5y. So I can find out what x is by doing the back substitution. So I just substitute the y here with 2. So the x is equal to 15 minus 5 times y, which is 2. And then 15 minus 5 times 2, that's 10. What's 15 minus 10? 5. So here x is equal to 5. And y is equal to 2. So my ordered pair for this system of equations will be 5, 2. Okay. All right, any questions about using the substitution method to solve a system of equations? Okay. All right, next we'll look at the other way of solving a system of equations, and that is the elimination method. Okay. The main idea for solving a system of equations using the elimination method is to add or subtract equations in order to eliminate a variable. Okay. Some textbooks call it the add or subtract method, which is the same as the elimination method. And the result that you get is going to be a one-step equation, which is going to be a simple problem that we already know how to solve. All right, so first thing you want to do there is make sure that both equations are in standard form. And of course, standard form is always ax plus by is equal to c, meaning the x and the y are on the left side, the constant term is on the right side of the equal sign. Now, the second step, now might not be necessary, but if it is, you may have to multiply both sides of the equation by a suitable real number so that one of those variables will be eliminated by adding the equations. May have to multiply either the first or the second, or you may have to do both, because you want to do that in a way so that way you can eliminate either, let's say, the X or the Y. And then you'll add the equations and solve the equation, solve that resulting equation. And then you're going to substitute that value into one of the original equations and solve that equation. And if necessary, check your solution and then write the solution as a ordered pair. Okay, so let's say in this example that we have down here, we got 5x plus 2y is equal to 24, and negative 5x plus 6y is equal to negative 8. Here I picked an easy one for you to start off with as an example. The other one we will pretty much have to do a little work on that one. All right, so let's start with part A. I'm going to write these underneath each other. 5x plus 2y is equal to 24. And the other one was negative 5x plus 6y equals negative 8. Well, in this case here, they're both written in standard form where the x and the y are on the left side of the equal sign and the constant term is on the right side of that equal sign. Now, we don't need to multiply either the first or the second or both of these equations by some suitable number, because look here, we got 5x and negative 5x. Can we go ahead and just add those two equations together and that will eliminate the 5x? Yeah, we can do that. So here the 5x and negative 5x, that's gone. Now we add 2y and 6y. Now the 8y equals 24 plus negative 8, 16. So here we have an equation in a single variable that we can solve. We got 8y equals 16. So what must y be equal to here? 2. When we divide both sides by 8, y is equal to 2. So we know what y is. Now we could use either the first equation or the second equation to find out what x is going to be. So in this case here, I'll use that first equation. 5x plus 2y is equal to 24. And then substitute the y with 2. So I got 5x plus 2 times y, which is 2, and that's equal to 24. Two times 2 will be 4, so 5x plus 4 is equal to 24. Then to get that 5x by itself, we subtract 4. We get 5x is equal to 20. Divide both sides by 5. That would mean x is equal to 4. So we know what x is, that's 4, and the y is already 2. So for this system of equations, that ordered pair, we put the x first, that will be 4. The y comes after that, that'll be 2. So the ordered pair 4, 2 is the solution for that system of equations. Okay. Questions on part A? Okay, now part B. So we have this 2x minus y equals 1, 3x plus 4y is equal to 21. And here I want to solve this system of equations here. Well, now we got a problem here because we're not going to be able to add these two equations as is in order to eliminate either the x or the y. So that means we need to multiply by some suitable number where we can eliminate either an x or a y. By looking at this, it would be easy for me to eliminate the y because notice I have a minus sign and a plus sign already there. And notice in the second equation, I have a 4y. If I want to eliminate the y, I need to make this 1y a 4y. And to do that, I need to multiply both sides of this equation by 4. Here I need to multiply the top equation by 4. That way, I will have a minus 4y and a plus 4y, where I can eliminate the y's. So when I do that, on this side, 4 times 2x will be 8x, minus 4 times y, that'd be 4y. That's equal to 1 times 4, which is 4. And here I bring over the 3x plus 4y is equal to 21. And now I can eliminate the y's, the minus 4y and the plus 4y. When I add those equations, those 4y's are gone. So 8x and 3x will give me 11x, and that's equal to 4 plus 21 would be 25. So I got 11x is equal to 25. And when I divide both sides by 11, and I'm going to leave that as a improper fraction. I'm going to have x is equal to 25 over 11. Okay, now we can use either the first equation or the second equation. Solve for x. I use the first equation. And then substitute the x with 25 over 11. So I get 2 times 25 over 11 minus y is equal to 1. And if I put that 2 over 1, 2 times 25 will be 50 over 1 times 11 will be 11. So it'll be 50 over 11 minus y is equal to 1. So I'm going to subtract 50 over 11 on both sides. This will be negative y is equal to, and let's think about this. That 1, how many 11ths are there in one whole? It's actually 11, because 11 over 11 does equal to 1. And then subtracting 50 over 11. So that means negative y is equal to, let's see, if I subtract 11 minus 50, what would I get? Negative 39. So I got negative y is equal to negative 39 over 11. And then in this case here, if I multiply both sides by negative 1, the opposite of negative y will be y, and the opposite of negative 39 over 11 would be just 39 over 11. So your solution is in the ordered pairs of fractions here, 25 elevenths, 39 elevenths. Okay. Now, the other way I was thinking about was doing that again, but this time eliminating the x's instead of the y's. And then I can come up with my y value. Okay.
Do you always leave it as an improper fraction?
Yeah, I would, yes. Any other questions? Okay. And by the way, if you were to graph that on a coordinate plane, you would not be able to know that the solution set for that system of equations would be 25 elevenths, 39 elevenths. Okay. Okay, next we'll look at solutions of systems of linear equations. If you were doing this on the coordinate plane, geometrically, a system of two linear equations can be characterized as follows. The system will have a unique solution if and only if the graphs of the equations intersect a single point. Or it could have no solution if and only if the equations represent parallel lines, and the system has infinitely many solutions if and only if the equations represent the same line. And the way you can determine that would be to solve both equations by getting y by themselves for each one. And of course, when you solve an equation for y, you're going to have it in slope-intercept form, which is y equal mx plus b. And we identify the slope. If the slopes are different, that means that the system has a unique solution. If the slopes are different, you have a unique solution. If the slope is the same on both, but the y-intercepts are different, that means you will have no solution for that system. That means that the two lines are going to be parallel. And if the slope and the y-intercept are the same for both, that means that system will have infinitely many solutions. That means one line will lie on top of the other, like in this example here. Let's say I want to solve each of the following systems if possible. Okay. So in this case here, in part A, we got 2x plus 8y is equal to 3. And 3x plus 12y is equal to 4. And here I want to determine whether this system has a unique solution, no solution, or infinitely many solutions. So each one of these we're going to solve for y and identify the slope to see what's going on. I started with that 2x plus 8y is equal to 3. So to get y by itself, or the 8y by itself, I need to subtract 2x on both sides. So that means I have 8y is equal to, I'm going to put the negative 2x in front, and then plus 3. So to solve for y, we divide each and every term in that equation by 8. So this will be y is equal to negative 2/8 in simplest form would be what? 1/4. So this is negative 1/4 x plus 3/8. 3/8. So I need to identify the slope and the y-intercept here. The slope here is the coefficient of x. That's -1/4. The y-intercept is that constant right behind it, 3/8. Okay, let's do the same thing for the 3x plus 12y is equal to 4. So to get 12y by itself, I need to subtract 3x on both sides. So that means I have 12y is equal to -3x plus 4. And then solve for y is being multiplied by 12. I need to divide each and every term by 12. So that means y is equal to, what's -3/12 in simplest form? 1/4, or -1/4 x. And then 4/12 in simplest form, 1/3. So the slope here is -1/4. The y-intercept is 1/3. Let's compare those two. What do we notice about the slope? They're the same. And the y-intercept is different. Same slope, but different y-intercept. That means that this system of equation has no solution. That means if I was to graph those two lines on the coordinate plane, they're not going to intersect, they're going to be parallel. Questions on part A? Okay, let's look at part B. Here we got 4x plus 6y is equal to 3. 6x plus 9y is equal to 4.5. On determinant, those two lines have one unique solution, infinitely many solutions, or no solution. Let's start with that first equation, 4x plus 6y is equal to 3. Well, let's first solve for y by subtracting 4x on both sides. So 6y is equal to -4x plus 3. Divide each and every term in that equation by 6. Now, what's -4/6 in simplest form? -2/3. So this is -2/3 x. 3/6 in simplest form, 1/2. So the slope there is the coefficient of x as 2/3. The y-intercept is your 1/2. And now let's do 6x plus y equals 4.5. Here we're going to solve for y by subtracting 6x on both sides. So that means 9y is equal to -6x plus 4.5. And we're going to divide each and every term by 9. So that means y is equal to -6/9 in simplest form would be -2/3. So it'll be y equal to -2/3 x. 4.5 divided by 9. That'd be 1/2. Okay. And notice that those equations are the same. Same slope of 2/3 and the same y-intercept of 1/2. Here I got the same slope and the same y-intercept. That means that this system of equations will have infinitely many solutions. Infinitely many solutions. All right, questions on part B? Okay. And again, we're gonna have to pause right here on this section